All right, here's a second example. So we're going to, again, solve this polynomial inequality. We are going to give our answer in interval form. So let's go ahead and get started. First thing we wanted to make sure is that everything was on one side of the inequality and 0 on the other, which it's already set up that way, so that's great. The next thing we need to do is write down our possible rational zeros. Okay, so factors of 48, which there are many. Positive or negative 48, positive or negative 1, positive or negative 24, positive or negative 2, positive or negative 16, and 3 gives us 48. Positive or negative 12 and 4 and then positive or negative 8 and 6. Okay, so I believe that's all of the factors of 48. We start from there. I'm just going to look for rational zeros, so I'm just going to start testing numbers and see how it goes. Okay, so again, I'm going to write down my leading coefficients. I have 1 and then 5, 6, negative 16, negative 48. Just choose any of these numbers. Okay, let's say I chose 2. Let's try 2. Okay, so we start out and we drop our number down. 2 times 1 is 2. 5 plus 2 is 7. 2 times 7 gives me 14. 6 plus 14 is 20. 2 times 20 is 40. 40 and a negative 16 is 24. 2 times 24 is 48, and I get a 0. I just happened to get lucky there. Okay, and remember, we know it's one of our zeros if our last number, our remainder here, comes out as a 0. The other thing that I noticed is, see how all of these came out with the same sign? They're all positive, all these numbers. That means this is an upper bound. So as I'm continuing to look for zeros, I know it can't be anything bigger than 2. It might be 2 again, but it can't be anything larger than 2. Okay, the other thing I could do is write down the polynomial I have left now. I was at an x to the 4th. I found this 0. That drops me down to an x to the 3rd because I divided basically by an x. So my new polynomial I'm working with is 1x to the 3rd, a 7x squared, 20x plus 24. So notice for my possible zeros now, as I'm testing this one, I just have factors of 24 that I would be working with, which doesn't take out a lot of my options, but it might help a little bit. Again, I know my upper bound is at 2, so I'm not even going to try anything larger than that. So I'm starting with my smaller one I've broken down to. You don't want to start back here. Okay, start with your smaller one. It helps. And I need to do things smaller than 2. So let's try 1. 1 times 1 is 1. 7 plus 1 is 8. 1 times 8 is 8. 20 plus 8 is 28. 1 times 28 is 28, and you can see we have a very large number there. And I did get a really large number, so I know I'm probably way off with my 0. I need to go something much smaller than positive 1, so I'm going to dip down into the negatives. Again, if you use a graphing calculator, this would be much easier because I could just see where they are approximately and go from there. But since I'm not, I'm doing it totally without graphing, and you don't have to. You can use the calculator, but if you do it without graphing, this is what we go through. Lots of testing. So we drop our first one straight down, multiply. 7 minus 2 is 5. And you might ask how I'm picking my zeros. Really, I'm just picking my zeros. Okay. Notice this one, when I get to the end, I have 4 as my remainder, so I'm getting much closer to 0. So I know I'm on the right track. I'm going to keep getting smaller. So let's try -3 because that was one of our possible zeros. Go back to our a little bit smaller function and go from there. Oh, look at that. Lucky day. -3 is also a 0. And the really good thing about that is I went from an x to the 4th to an x to the 3rd when I found my first 0, and now I've gone from an x to the 3rd to an x squared. And I don't have to test any more things. I know that I am very close here. I can, once you get to an x squared, you can either factor or use the quadratic formula. So here I have 2 zeros to a -3. And I've broken this down. Now my remaining polynomial is x squared plus 4x plus 8, and I'm going to go from there. I want to solve this, so I would factor, but this does not factor. There are no factors of 8 that add to equal 4. So instead I use the quadratic formula, which, remember, this is a is in front of x squared, b is in front of x, and c is my constant on the end. This is something very handy to know in this class, so that you can use it. And the quadratic formula says -b plus or minus the square root of b squared minus 4ac all over 2a, and I substitute my values in. So my b was 4, so I have -4 plus or minus the square root of 4 squared minus 4 times my a was 1 in front of the x squared, and my c was 8 on the end there, all over 2 times my a, which again was 1. If I simplify the part underneath the root, 4 squared is 16. This gives me 16 minus 32, which, notice there's a problem with that. The problem with that is that under the root I get -16, because 16 minus 32 is -16. The square root of -16 is an imaginary number, a complex number, and we're only looking for real zeros here. So I know the remaining zeros are imaginary or complex numbers, and I don't need to use them in this problem because we're only working with reals. So I'm done finding zeros. My two real zeros were 2 and -3. If I were just finding zeros, I would be done, but I'm not. I'm solving an inequality. So what I have to do is take those 2 zeros that I found, place them on a number line in their proper order, smaller numbers to the left, larger numbers to the right, and test each interval. We only have 3 to test this time, so I need to test a number less than -3, say -4, a number between -3 and 2, say 0, and a number bigger than 2, say 3. Okay, we're going to go ahead and test those in our inequality, and what we're looking for is we're substituting the value in and checking to see is it greater than 0 there. If it is, it's part, that whole section is part of our answer. If it is not, that whole section is not part of our answer. Again, I'm going to use synthetic division to sub these in. It's called synthetic substitution, but you can just take the number and substitute it into your polynomial also. That's also an option. So I go back to my polynomial here. I'm going to evaluate -4 in the polynomial. Write down my coefficients. So I had 1, 5, 6, -16, and -48, and I get started. Okay, so we have -4 times 18, -18 is 72. 72 minus 48 gives me 24. Okay, so remember what that tells me is this is the value that if I were to put -4 into x in this polynomial, I would get 24 as my answer. Your remainder here is always that number. So I'm asking, does this value work? Is my answer that I got 24? And then look at your sign. It says greater than 0. Is it? Absolutely it is. So yes. So this is part of my answer. Okay. Now let's test a number between -3 and 2. 0 is always a good one to check. Let's try it out. So if I put 0, and again I'm just putting it into that polynomial that I started with. And this goes pretty fast when you have 0 because everything comes out to 0, and I end up with negative 48. So my question is, again, the answer I got here, if I were to put 0 in here, I would just get negative 48. Is negative 48 greater than 0? And hopefully you're saying that no, that's not the case. Since it's not, this entire section is not part of my answer. So my answer cannot be anything between negative 3 and 2. And then we test our last section of the graph, which is greater than 2. So we chose 3 as a number to check. Again, I go back to my original polynomial. Go ahead and get started. Get 8 times 3 is 24. 24 plus 6 is 30. 30, there we go. 3 times 30 is 90. Negative 16 plus 90 is 74. 74 times 3 is, we are getting very big here, 222 minus 48 gives me 174. So if I were to put 3 in there, that's what I would get. Now again, what I was trying to find out here is that greater than 0 like they wanted it? Is 174 greater than 0? Very much so. So this would be a yes also. It fits my inequality. So this section is also part of my answer. So my answer is everything to the left or everything less than negative 3, and then everything from 2 to infinity, everything greater than 2. Now what you want to watch here is, we know we're going from negative infinity to negative 3. Notice I put the smaller number to the left, the bigger number to the right. Infinity always has a parenthesis on it. We want to know, what do we use on negative 3? Is it going to be a parenthesis or one of those squared brackets? Look over here. Is there an equal to? There is not. If there's not an equal to, you always use a parenthesis. Put a little union to join our two sections together, and then we're going from 2 to infinity. Okay? Infinity always gets the parenthesis, and then we go again. Okay, we only wanted answers greater than, not equal to 0, so we don't want to include the 2. We use a parenthesis there. So there's our answer. It's negative infinity to negative 3, union with 2 to infinity.